Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Hello, everyone. I'd like to introduce our guest speakers for today and then let them take over the show. They're three actually recently graduated, as in today, I think, from the HCI program at University of Washington. This is Saba Kawas, Emerline Wu, and George Carolus, who I've had the pleasure to work with very closely over the past year on scenarios around the deaf and hard of hearing. And I won't take from their show here. This is Project Skrybe. Saba, take it away.
Thank you. Thank you, Will. So hello, everyone. Thank you again for attending our talk this morning. We are Team Skype, as Will mentioned. My name is Saba Kawas. I'm a PhD student at the University of Washington Information School. These are my teammates, George Corrales, a program manager at the Microsoft Edge team, Emerline Wu, a user researcher at UpTop. And today, we'll be presenting how can we design features to improve real-time captioning experiences for deaf and hard of hearing students. This work, as Will has mentioned, was part of our capstone research project. So today, real-time captioning services provide access for deaf and hard of hearing students to access mainstream classrooms. Real-time captioning is a system or a service that converts spoken word into visual text with high accuracy in real time with a little delay or lag. Deaf and hard of hearing students may choose captioning services over sign language because they are less fluent with sign language than with English. So for example, a deaf or hard of hearing students that uses in-person captioning services would, in their classrooms, in their mainstream classroom, would sit next to their captioner, who and also refers to the caption that displays on the captioner's computer, while also paying attention to both the presentation and the teacher. So the captioner usually comes into the classroom before the class starts and sets up the stenograph and the laptop that displays the caption. So the stenograph in this photo is actually in front of it's hidden by the captioner, it's in front of him, and it looks like this. So stenograph, or captioners, basically use these shorthand typing keyboards that enables transcription at the speed of speech. This keyboard maps multiple keystrokes to a phoneme of a word, which then expands into a verbatim full text into the captioning screen, where the students will have access to it and read. So although these captioning services provide deaf and hard of hearing students access to mainstream classrooms, they were not designed with deaf and hard of hearing students in mind. These existing services and solutions that utilizes human captioners or even sign language interpreters are costly and put those options out of reach for budget-conscious schools. So automatic speech recognition technology, like the one is developed by Microsoft Translator here at Building 99, has the opportunity to provide low-cost machine-generated captions, where it usually converts spoken word into text to benefit deaf and hard of hearing in mainstream classrooms. So in our research, we wanted to take a broad approach to user experience for both existing solution and that utilizes human captioners and potential solutions that leverages ASR that converts speech to text in real time. So for our overarching research question, we wanted to know how can we improve classroom captioning experiences for deaf and hard of hearing students in classrooms with hearing teachers and classmates. So in this talk, we'll cover related research that has been done in this field. This is also the only research that we know of that conducted a variety of qualitative HCI research methods with both existing and potential captioning solutions. And we really wanted to understand deaf and hard of hearing needs, experiences, and perspective using these solutions. Our research results affirms that accuracy is still the most important aspect of captioning. However, we did uncover a variety of user experience shortcomings, such as complex setups. We also learned that current solutions may limit students' autonomy. We're also the first to conduct a co-design workshop to include deaf and hard of hearing and other stakeholders in the design process. The main contribution of this work is a design recommendations and a feature list to help solve these user experience problems that could be implemented into existing or new, real-time captioning systems such as ASR. I'm going to hand it over to Emmeline to walk us through related work in this field.
Thank you, Sarah. Okay, and we are going to look at solutions that are commonly used today, potential ASR solutions, and other experimental technology that attempted in academia. CART, computer-aided access real-time, which is widely known as CART, as the most reliable and widely used transcribing service in the classroom setting. And it is word-for-word speech-to-text captioning. It can be done in person or over a remote call. As Saba mentioned before, the stenographer uses a stenographic keyboard to type up to 225 words per minute. And in order to be a certified CART provider, one has to reach the accuracy of 98% and more than 225 words per minute, and also 2 to 3 years of training. And thus make it, there's about a few hundreds of certified CART captioner providers in the whole United States. And thus that makes it very high cost, which is about $100 to $200 per hour. And we can see here's a CART provider with his computer and the stenography typer here. Okay. And next we move on to CPRI and Typewell. CPRI and Typewell are another captioning service that's available in the classroom setting as well. The difference between CART, CPRI, and Typewell is that CPRI and Typewell is meaning for meaning, while CART is word for word. And what does that mean? It means that CPRI and Typewell captioner are trained in text condensed strategy, and that include as much information as possible. That's right. To be a CPRI, what did I do? Sorry. Oh, there we go. Okay. CPRI and Typewell captioner takes about a year to be trained. And thus, it's less costly than CART. It's about $50 per hour. And it's not widely used in the university.
Question on going back to CART, because of the level of qualifications, the number of CART stenographers across the country is fairly limited, correct? We're only looking less than 300 people. Is that correct?
Around 300 something. Last time we looked at the papers, but it might be.
This is also from 2013.
Yeah.
I see. Okay.
And it might also just limit it to the availability for the higher ed. They can be also, that's actually also CART providers for court reporting. So the number might be more on there.
I see.
Yeah. Okay. So let's move on to the next one. So automatic speech recognition, ASR, is a technology that recognizes and transcribes spoken language into written text in real time. And here's a diagram that explains how, and I'm not going to detail on it because most people here might know more than I do. Okay. ASR has a wide range of applications, and they tend to be personal or one-on-one communication. For example, Dragon Natural Speech software is known for providing high-quality speech-to-text memo detection. Cortana as a supporting digital personal assistant that makes search much easier, and Skype Translator converts speech to text and provides machine translation in real time over the Skype phone call, allowing speakers of different languages to communicate. And note that this kind of application was not designed for real-time captioning in the classroom settings. With the improvement in accuracy for ASR for the past year, it offers a new opportunity to apply ASR in classroom setting for real-time captioning. And there are academic research that focus just on that. For example, eScribe at Pinta. eScribe proposed a ASR captioning solution for deaf and hard students using a web-based technology. Pinta provides a automatic speech-to-text, text-to-speech on multiple platforms for deaf and hard students inside and outside classroom. And the diagram here shows how a Pinta works. So the teacher speech was transferred from the phone to the internet and through the Pinta server, and it will be displayed on the computer so that the student can see. However, there are only academic research and not used outside those environments. And they also only look at accuracy rather than usability or the display of the captioning. Okay. And other approaches to classroom captioning, we've been talking about existing and other up-and-coming technology for captioning service, and here are some other approaches that for classroom captioning that is not focused on technology. For example, Legion Scribe here. Legion Scribe is focusing on reducing the cost for captioning. Like I mentioned before, CAR is $100 to $200 per hour, and they're trying to reduce that by using crowdsourcing with non-professional captioners. And here's how Legion Scribe works. There we go. The speech is transferred to the media here, and I have 3 or more captioners trying to type it in. It's being through the merging server, and then merge the captions and then output into whatever platform they're looking at. And classroom, another approaches are looking at technology that focus on divided attention. For example, classroom focus, looking at how to get students' attention by wiggling the edges of the display, and projected track speech-to-text display projected onto the, you can see it here, the text, oops, sorry, the text, technology fields. Here, the text here is right above the speaker here. They're looking at divided attentions in the classroom settings. Okay. However, none of the research that we have been looking at has been used outside academia. And they're only looking at the accuracy rather than the usability or form factor or the display of the captioning. And we wanted to look at those. And to look at those and design features that address user experience. So for our research, we apply a variety of HCI methods on both existing solutions and possible ASR solutions. So we use observations, interviews, diary studies, and Skype Translator evaluations. The use of variety methods allow us to triangulate the data that we collected and help us uncover subtleties that we would not otherwise uncover just with one method alone. So that's why we have 4 methods. Okay. For in-classroom observation, we sat in 5 classes with 2 deaf and hard students to observe the setup of the preferred accommodation activities and the issues that encounter and other general behaviors. And here's a picture that we took during one of our observations. Here's the professor talking on the screen and the students sitting just about here. Okay. And next, our diary studies. We have our participants keep a diary of 5 classes within a week, and we ask them to document in their in-class experience frustration and difficulties with questions like, did you encounter any difficulty or frustration during the class? Diary study is one of the least intrusive methods for participants to express important and sensitive information on their thoughts and feelings. And that's why we use the diary study for our research. And here's a screenshot of what our diary entry looks like. You can see it just takes about 5 minutes to fill it up after each class. And we conducted a semi-structured interview with our participants, ask them about their current in-class captioning experience, and also to follow up on specific things that we observed in class or read about in their diary study. Here's one of our participants holding up her coherent plan, explaining to us how that works for her. Likewise, we conducted an interview with our other stakeholders, professors, disability service coordinator, and captioners to get a more holistic view of the students' experience in the classrooms. Like we mentioned before, that we wanted to bring ASR into the classroom to see if ASR is a viable solution for real-time captioning in classroom setting. And for here, we brought Skype Translator into the classroom. As you can see in the picture here, we have 2 computers that can make a Skype phone call and audio input from the lecturer's mic. Audio input from the lecturer's mic that's directly fed into the computer via a wireless transmitter. Our participants sat in the lecture and following the captioning in real time, and afterwards, we asked them to fill out a survey about their experiences. We coded the data from our diary, observations, interviews, and Skype Translator evaluation, and conduct a qualitative analysis using affinity diagram. And here's what an affinity diagram looks like. And we identify emerging insights through a thematic analysis. And George will take over and talk about the results.
Hi, everyone. So from all of our methods, we aggregated the findings and we organized them into different groups, like what are the benefits of certain solutions, the limitations, technical problems, frustrations, those kind of things. And then we broke them up based on what was specific to a particular solution as opposed to more general findings. And so let's first talk about CART specifically and the benefits and limitations there. I'll remind you, CART is the most widely used service right now, and it's where there's a person sitting there typing on a stenographic keyboard and the captions show up on a laptop. And so the major benefits of CART, overall, students are very satisfied with CART, and it has a lot to do with the accuracy. And there's a bunch of factors that contribute to the accuracy. As mentioned before, the captioners are trained to type at very high accuracy, but in addition, they're correcting the transcript both during the class and then during breaks and after the class, so they're able to provide an almost perfect quality transcript by the end of the course. As one student says, I'm completely satisfied. We heard that a lot. Another major benefit is that even though there is quite a setup, there's the stenographic keyboard, there's a person there, there's a laptop that needs to be set up, the professional captioner is the person who's responsible for that setup. So the student really doesn't worry about that. They just show up and their captions are available to them. And another thing that a human captioner is able to do is indicate when multiple speakers are talking, create natural language breaks in the display of the captions, so it's a lot easier for the student to follow along. There were some limitations of CART that we identified, though. Even though CART is the most accurate captioning solution, there's still kind of variability in how the quality is depending on the course subject. So courses like science or math can be really difficult to caption if there are domain-specific words or with scientific notation or mathematical notation that can be very difficult to capture. And the captioner's expertise can vary as well. The setup can be kind of limiting to students. We have a quote here, as this student says, "You have to be near an outlet. I was once in an auditorium where there was only one outlet." So clearly that limits where the student's able to sit. That kind of setup can draw attention, and it could kind of limit their autonomy overall. And the last limitation is that captioners, because they're people, they can be unavailable. As mentioned before, there's a very limited number of them available to higher ed, and they could be late to classes, they could be on vacation or sick, and that can create a lot of problems for students. So in this quote, "My captioner usually has to be 5 minutes late because she is speed walking all the way from South Campus to North Campus." And so during those 5 minutes, the student just doesn't have access to her course material. And the last one is the high cost. And this is not something that students worry about so much, but when we talked with disability service coordinators, they definitely had this in mind. And that kind of affects how often these captioners can be scheduled and sort of that aspect. So now we'll move on to Skype Translator, and this was our way of evaluating ASR as a potential solution for classroom captioning. And as Emerald explained, we had two computers. One of them was connected to the speaker's microphone. The other was for displaying the captions. We initiated a Skype call between them and then enabled captioning through Skype Translator. And so we did identify some benefits of this kind of solution. Overall, students felt more autonomous because they weren't relying on a person to be there. They didn't need to schedule. They could sit wherever they wanted to. And the interface was more intuitive. So as this student says, "It is easy to follow along. I can always look back at the captions if I'm not understanding something. I can scroll back up to see what the speaker said before, and it seems intuitive to use." And that was really a key finding, that students felt like they were more in control of the captions and of the display of the captions. Again, no scheduling was required. They felt like with this solution, they could really just show up, use their own personal computer rather than equipment provided by the captioning service. And overall, they were in more control. And then, of course, the cost is much lower than that of a human captioner. We did encounter quite a few limitations with Skype Translator as it is right now, though. The biggest one by far was that the captioning quality was just not at the same level as CART. So as this student says, the translator was not accurate sometimes, which made it difficult to follow along with. And overall, I think students expressed this, that really it wasn't up to their expectations as far as quality goes. Another thing is that in order for ASR to work, you need to have anybody who's speaking mic'd up. And as this student says, there was only one microphone, so I couldn't get the student questions translated. When there's a human there, they can just listen to whoever's speaking and make sure that that's captured in the captions. Whereas with Skype Translator, the student wasn't wearing a microphone, so it wasn't showing up on the screen. And the setup was pretty complicated with Skype Translator. As I mentioned before, we had two computers. We needed to initiate a call. We had to arrange beforehand to make sure we had access to the audio feed so that we could get that into the computer. And so it's definitely too complicated for a student to be responsible for setting up as the form factor exists today. Beyond the specific solutions that we evaluated, we found some general frustrations and user experience issues across all the solutions that exist today. The first one is in particular environments, the quality of the captions can degrade, particularly in noisy environments. And so as this student says about CART captioning, one area we struggle is when we have a breakout session, it becomes really noisy. It can be hard to hear even for the CART transcriber. And that's an issue that absolutely affects ASR too. Another thing that we encountered is that the speaker's behavior can have a major impact on the quality of the captioning, both for CART and for ASR. And so speakers can speak too fast or not clearly enough, or in general, the way that they conduct their class could affect the accessibility of their class. So as this student says, if the professor talked slower, the transcriber would be able to provide better transcripts. It would also help if the professor did not go through the slides very quickly so that I could read both the slides and the transcript at once.
comment for anything.
Yeah.
Even with the interpreter, right here like this, I'm still stuck. I look at that or I look at that. Sometimes I just say, time out.
Totally, yeah. I hope I'm doing an okay job. Another area. Take your time, Ted. So another issue that was common across all solutions is that technology would fail in a variety of ways. And with CART, for example, we saw one case where the whole system crashed and the captioner had to restart the system. And during that period, the student just wasn't able to access the course material. And of course, we experienced similar connectivity issues with Skype Translator. And I actually didn't mention before, with Skype Translator, you do need an accurate and kind of reliable internet connection, which is, of course, not always the case.
So one credit card also offers offline too, so you can have someone who's remote. Is that correct? So
Yes,
if
that's
they
true.
don't have a transcriber available, they can do something remote.
That's right.
You'll have the connectivity issues there too then. If you're
Yes, yeah. So if you're using CART remotely, you can call into the CART service and have a captioner kind of listen remotely and then transcribe, and that would have very similar issues. That's right.
And I can tell you that that is really a much more an exacerbation of the noise issues, speaker accent issues, and so forth. I've had remote CART, from meetings here sometimes where it was just, I couldn't understand.
Mm-hmm. Totally, yeah, and ASR experiences a lot of those issues too.
Do we have Skype on the internet?
Can you say that again?
Do we have Skype on the internet? I mean, not on the internet, but just through LAN.
Oh, can you use Skype Translator without actually going to the cloud? So from what I understand, the way the technology works is it is server side, so all the transcription happens in the cloud.
Our service in the cloud.
That's right.
Okay.
Okay, so that's kind of the overall results that we came up with, very high level. And from there, we wanted to determine how we could adapt the results into design requirements that technology providers could use to improve these solutions. And so we came up with a list of design considerations. I won't read through them all. We prioritized them, and later we reprioritized them based on new findings that we came up with that we'll talk about soon. And then with these design considerations, we started sketching and trying to develop feature ideas to address some of those requirements. And we iterated from rough sketches up to this sort of mid-fidelity wireframe level. And we kind of tried to develop interfaces that expressed some of the features that we think would start to solve the issues that we talked about before. And we next took these mid-fidelity wireframes into a co-design and evaluation workshop.
So we then organized a co-design workshop to engage deaf and hard of hearing students, to engage both deaf and hard of hearing students and other stakeholders in the design process. We also wanted to gather more information about what other issues that deaf and hard of hearing students currently face in the classroom, and what other limitations that was out there that we didn't observe. And that was a way actually to validate our peer findings. We also wanted to brainstorm new solutions and come up with design ideas with our stakeholders, specifically deaf and hard of hearing students. We also evaluated our feature ideas that we came up with earlier on. And the goal here also, we wanted to prioritize how important or less important for specifically deaf and hard of hearing. So these were our participants from all our stakeholders across solutions, including deaf and hard of hearing students and hearing students as well. You might recognize some of the people in this picture. So for the workshop activities, we structured the different workshop activities to ensure that we're making our stakeholders comfortable enough to talk about their ideas, as well as express solutions through sketching. So we started off with an icebreaker activity. Then we actually asked participants individually to critique current solutions and list current limitations on a Post-it note. Then we grouped, as a group, we gathered as a group, and we analyzed, as you can see here, we analyzed the data And we grouped them in the ad hoc categories that prioritize. We wanted to prioritize basically these issues. We asked participants then to imagine new solutions for the limitations that was pinpointed earlier in the critique session. So here, everybody, including us, we were actually participating in the brainstorm and the drawing. And we went around the table, and every participant were displaying or explaining their solutions. So the last activity of the workshop, we really evaluated, again, as I mentioned, the feature designs that we came up with earlier. At the end, we thanked our participants for joining us in the workshop, and we handed them an honorarium that was provided by MSR. So thank you. The workshop lasted around 2 hours with a dinner break. Okay. So in the imagined solutions, participants came up with creative and forward-thinking solutions. However, a common theme across all the imagined ideas that we saw is we uncovered that students really emphasized their desire for autonomy and with the solutions that they came up with. So some of these solutions were very futuristic, like displaying captions in a HoloLens. Or the users will wear a contact lens that beams captioning into their eyes. Another interesting solution that was holograms that would either display on top of the speaker head or projected on an armrest wearable. So other solutions were more grounded and practical for implementation, such I want to be in control of my caption where I can scroll back. I also want control of the font size or the color of the background or the text, as well as the screen brightness. A lot of the students mentioned that in dimmed classrooms, that was an issue for the screen to be very bright, where it was not their device, so they had no control of dimming it. So for the future evaluation, we walked through the mid-fidelity wireframes with the participants, and we asked them to rate features and importance. And we collected their written feedback on why they chose that rating. And there were pizza, too. So from the critique phase that we ran with our deaf and hard of hearing and other stakeholders, we found that most limitations voiced by participants match closely to our earlier finding and the results that George presented earlier. So caption accuracy is still the top issue across all solutions. Students, again, wanted control over the presentation of the captions, especially the ability to scroll back to previous text, or simply the control of the font size and the background color. Setup was definitely one of the biggest issues, and this is, again, aligns what we found across potential solutions and existing solutions. The frequent technical issues without good communications of troubleshooting was also a big issue in accessing the content in the classroom. So these were among the top problems with existing solutions, and this is specifically really aligns with our past findings from our previous research methods. So we also did uncover new learnings. So for example, students really didn't want to coordinate with teachers before each class to set up the accommodation. Like for example, the Microsoft Translator, there was an instant where they had to go before every class and ask the teacher to wear the microphone. Student wished captions would indicate speaker tones and emotion. We also noticed changes in priority, and this is really from our design recommendations and the feature list that we came up with earlier that we kind of displayed, but we didn't talk over it really quickly. So, this is from our understanding of our previous findings, right? We found that some of these recommendations were a higher priority than we originally realized. So, for example, deaf and hard of hearing deemed for teachers not to speak too fast to be extremely important, something that we didn't expect. We also, indicating multiple speaker within the caption was very important. And earlier on, it was not one of our top priorities. There were also other design recommendations that we found. Oops, sorry. That were less important for deaf and hard of hearing students, and that was kind of unexpected for us. So one example was viewing past transcripts and providing deaf and hard of hearing students with the option to correct the caption errors in real time. So what does that all mean? So if we're actually trying to design caption solutions for deaf and hard of hearing students, there were actually 3 major factors that we need to really consider. So technical factors, specifically accuracy. So ASR systems won't be a viable solution as the captioning services unless accuracy is on par with CART. Setup is still complicated across all solutions, but remember,
the accuracy with CART, you mean CART at real time or the CART post-edit? Because they do the post-editing. The CART stenographer will do the post-editing.
yes.
Too.
Yes.
So is the expectation to have the post-edits be at the same accuracy or the real time?
So the post-edit will make the transcript 100% accurate, right?
Right.
So I think it depends. Again, we surfaced some issues, right, for higher ed. So 80 to 90% is what happens in real time, right? This is like an ad hoc percentage based on really observation, so we can't really even conclude that, right?
So the expectation is to have 80 to 90% accuracy real time.
Right. So the setup is complicated.
That accuracy thing, it's not really accuracy per se, it's timeliness as well, a latency issue as well. If you get captions, even if they're accurate, but they're lagging too much, and you can't coordinate them with the visual thing as well. That's another factor that fits in there as well, for the accuracy and timeliness.
Oh, that's a really good point. Yes. So yes, reliability on providing captioning in a timely manner. Hence the real-time captioning. Okay. So the setup is complicated across all solutions, but remember that a professional captioner is responsible for setting up in the CART scenario. So unless ASR systems will face serious adaptation difficulties unless they address complex setup issues. So reliability is another major technical factor. So all captioning solutions that we observed suffered from errors and crashes, and with really poor feedback for troubleshooting. However, remember again, the CART captioner may have a little bit of experience of how to troubleshoot, and it's their responsibility versus the student responsibility. So we also uncovered social and behavioral factors. So again, as we learned, trained CART captioners are limited resource. But we also uncovered scheduling issues. So even when the captioners are available, they can get sick, or they're out for vacation, or even as simple as late for class. And this is kind of hinders the user experience. So also the quality of the captions varies, again, depending on the skills and the years of experience, and the familiarity with the subject, the class subject, or domain-specific words in that particular classroom. Again, we're reiterating, so teachers' manners of speaking can definitely affect quality of the caption, and this is true for both CART and ASR. So actually, right now, teachers do not receive any specific instructions about how to accommodate deaf and hard of hearing students in their classes. So there's not really any resources for them. So for example, providing simple as like a teacher's guide with like best practices, such as speaking more slowly, repeating questions when they're asked for other students, will increase the quality of the caption as well as the experience for the deaf and hard of hearing students in the class. So another interesting factor that we found is that students really desired autonomy in their classes. So really, students preferred solutions where they could operate without coordinating with others, and lacked interest when the solutions would require them to actually talk to the teachers regularly, like before each class. Equipment setup is a limiting factor, and this often dictates where the student sits in the class. For example, they sometimes have to sit in the front of the class or an aisle seat where the captioner can set up his equipment, or even like find where's a closest outlet so the computer would not die during the class. Again, so students expressed a desire to customize the presentation of the captions to better suit their preference. So this included, again, the font size and the color. And as we discovered in the co-design workshop, they even wanted to control over the form factor of the screen brightness, and especially the ability to scroll back and refer to previous text. So based on these three major factors that emphasizes stakeholder needs and goals, and based on our reprioritized list that we showed earlier of the design recommendations, we created a feature list that translates these design considerations and recommendations into a form consumable by technology providers. But just remember that these features, really, our aim is to be implementation agnostic. So we designed what we call Skrybe app as an example of how we can implement these feature lists. And George will actually go over these feature lists with us.
Sure, so I'll talk through each one of the kind of specific solutions that we developed to try to address some of these in the form of these wireframes. There were really 6 features that we felt were really critical to improving the experience for real-time captioning for students. I'll go through each one of these. So first, some key things about the interface for viewing captions. Based on our findings, it's really important to make sure that the captioning display can indicate multiple speakers, that the layout is broken up into the way that natural language is spoken, and of course, being able to scroll back and really see earlier parts of the transcript so that students can go at their own pace. Second really important thing is when errors do occur, to communicate them clearly and give steps to troubleshoot. That's something that the current systems really aren't doing very well, and make sure that there's help available when students need it. In this feature, we wanted to address the complex setup case, and our way of doing that was to provide teachers with a microphone that they would keep for the entire semester or quarter, and would wear that during every class, so that the student would really just need to show up with their personal device and connect to the microphone. Maybe the student would also have a second spare microphone if there's another person speaking or if the teacher forgets or something. We wanted to address the accuracy issue. And the way we thought of that is by using dictionaries that the teachers or the students could upload course content into, so that domain-specific words for particular subjects could be recognized in the captioning. And the last one, as we've mentioned a bunch of times, really providing students with control over the presentation of the captions, with settings like font size, text color, background color, screen brightness. These are things that students constantly requested. And the last one that really would benefit all of these kinds of solutions is to make sure that the people who are speaking understand the best way to accommodate the students in their courses. And so some kind of teacher's guide or other best practices that can help remind teachers how to best kind of conduct their classes to accommodate the students in their classes is very important. And so to help illustrate these concepts, we created a video that we'll play now.
I have some hearing, but not enough to understand everything the teacher is saying. with just my hearing aids. So I like to use real-time captions because it lets me refer to the text when I don't hear something. I have a captioner sit with me in my classes and type captions in real time, and it works really well. The thing is, the captioning system does require a lot of equipment and set up at the beginning of every class. It can draw a little bit of attention, and maybe it may seem like I'm not as independent. And for certain subjects, the captions can be kind of off. For example, one time we were learning about SQL, the programming language SQL. Instead, the caption showed sequel, as in like a movie sequel. I like how Skrybe is aiming to design captioning just for deaf and hard of hearing students. And it's really cool that we've been involved in the process to help create something that suits our needs. Every teacher gets their own microphone, and all I would need to do is just bring my laptop to class, which I already do. And I also have a spare microphone that I can use if we break out into groups for a brainstorming session or something. And it seems really simple, but I think I'm giving the teachers material to help them speak more clearly will go a long way. I like how I can customize the captions to look and feel the way that I want to. And it's easy to scroll back to previous parts when I've missed something. I can also upload course content. This way, specialized words can be recognized in the Translator tool, like SQL, for example. It's good that there's messages when something goes wrong, and there's a feature for help where I can get assistance if I need it. I think Skrybe can really improve the experience for deaf and hard of hearing students, and I'm really looking forward to seeing this come out.
I think we're all excited for this to come out. So in conclusion, we took a holistic qualitative look at the experience of deaf and hard of hearing students with the captioning services across both existing and potential new solutions. For example, ASR. We also engaged deaf and hard of hearing students and other stakeholders in the design process, where we came up with the feature list and the design recommendation. So although accuracy and technical issues are still among the most problematic aspect of real-time captioning services and ASR tools, our research uncovered current captioning solutions tend to limit students' autonomy in the classroom and present a variety of user research experience shortcomings, such as complex setups, poor feedback, and limited control over the caption presentation. So again, our design recommendation and feature list aim to provide technology provider with actionable guidance to improve real-time captioning experiences for deaf and hard of hearing students. The feature aim to be implementation agnostic, such as they can be added to existing solution like CART or Skype Translator, or established classroom software like Microsoft PowerPoint, or maybe a new solution that we have yet to imagine. In conclusion, we really would like to thank our mentors, Richard Ladner, a professor at the computer science, who actually helped us and guide us through this research in the past 6 months, as well as Alyssa Sanuki. We also would like to thank the staff at the University of Washington, with whom we would have probably not been able to conduct this research. They helped us with the equipment setup, as well as reaching out on recruitment for our study. And at the end, and finally, we would like to thank our Microsoft research sponsor, Tan VWall and TED. So thank you very much. And I'll open the floor for questions. Do you guys want to join me up here?
Yeah.
Thank you.
What was the speech recognition engine that you used?
The Skype Translator.
It was Skype. Okay.
So I believe it uses Microsoft Translator, right?
Yeah, so speech translation. Yeah.
My experience is that people are often afraid of microphones, and I don't know why, but when I've been teaching classes, I've tried to get participants to use the mic anytime they had a question so that everybody in the room could hear, including me, because I have a hard time hearing in big rooms. And people are very resistant to it. And I wonder if that's something that you have investigated at all.
So as we discussed, we didn't necessarily interview specifically hearing students. The only time we had hearing students is with our workshop. So that didn't come up. However, that's definitely came up when the teacher is moderating the class. So the teachers has the ability, and I think they should really repeat the question, right? So right now I was not playing a good matter. Like I should have repeated the question. So I think that will be easier to address, right? I think we can reach out teachers because we know who they are, versus it would be a little bit more difficult to address the problem where students and every class have different students in it.
I guess I even wonder about the teachers, and maybe if there's such a clear need, they would be willing, but there's just, it's just.
So actually, surprisingly, that happens regularly in K-12.
Yeah.
So I was a middle school teacher, and that's something that we had to do, repeat questions, give time, so that we're trained like that, right? Classroom management, we call it. However, in the higher ed or university level, because they, I don't know, they call it reversed classrooms. There's so many other new tools that they use. They're less aware of their role as a teacher where they're moderating the classroom. So again, we didn't look at K-12. We only looked at the university level, but that's definitely, came up a lot. Do you guys have anything to add?
I mean, that's why we really tried to emphasize giving teachers the resources and the tools to make sure they know how to best conduct their classes so that they're accommodating the deaf and hard of hearing students that are part of their classes.
And to directly answer the question about microphone, the professors that we talk to are actually pretty nice. They're like, yeah, we are willing to do that for students if they approach us to do it. Yeah. And also, as part of the usability portfolio, they interviewed them and they were like, yeah, we are willing to do it.
That's true, yeah. We did interview teachers follow the study, and we did ask them that specific question. Some of them actually currently wear microphones because they run large classrooms, over 40, and they don't necessarily want to raise their voice. So the microphone makes it accessible even for hearing students.
And I think someone also mentioned that the FM system that the deaf and hard students using, it's also there's also mic to it, so they are used to it too if they have experience with deaf and hard students.
But I think this comes to best practices, right? So what I liked about one of the things you brought up here was the best practices guidelines. If you provide that as part of the service, then it's like encourages people to actually do that. But there are many scenarios where professors are having to do this. So for remote instruction, for instance, they're doing a lot of this at UW as well. And a lot of times you're getting questions that are coming on through IM or are not heard remotely. And the instructions that I was providing, for instance, when I was doing classes like that, was you need to repeat the question. So it's not completely just in the deaf and hard of hearing scenario, it's also in other scenarios where accommodating users who are not able to participate fully in the class, you need to actually accommodate them in some way.
Totally.
Just a curiosity on the user experience. If you have your typical user who is hard of hearing and is wearing, let's say, a microphone, if you were to tell that person, if I give you a better microphone, the system will work better, will have, let's say, a better transcription capability, but this microphone now is more visible. How do you think they would see that trade-off of visibility of the microphone versus quality of the experience?
That's a great question. So after we conducted this research, we did usability studies with a new thing that the Translator team is working on. The technology is a little rougher, so we needed to use headsets where the microphone was right by the person's mouth. And teachers were definitely way less interested in using that every class than a clip-on microphone. And really, that's what teachers brought up again. They're like, I don't have any problem wearing a microphone on my collar, like even holding a microphone. But when we got to the point where you're wearing a headset, that kind of put people off a little bit.
That's interesting because in the schools, though, I mean, in Seattle schools, we're asking the teachers to wear mics, but we did have to go with a mic that was very unobtrusive, like had very little impact. I mean,
So
was
it
just,
is really a big issue.
Yeah.
You're saying the visibility of the actual.
Yeah.
So they didn't mind, having a microphone where it displayed that they're the key speaker, but when it became visible and to the limit where it limits their hearing, right? They said no.
That's a problem.
Yeah.
Can a high quality microphone by the user capture it? Like one of the big ones that's expensive.
Well, like the Echo or something like this, so like a microphone array, perhaps in a device that's just sitting in the class. Is that what?
Yeah.
Rico, what? You'd be the best person to answer that.
That's not fair. That's a good question. I think microphone technology isn't quite there yet. So I think we're going to have to live with that trade-off for a while. Echo is an example. There are other similar efforts like that, including here at Microsoft, to come up with more capable devices. But this is still difficult to find that trade-off between good quality and invisibility of the device. So it's an active area. But I do see things getting better over time.
So it's not surprising that the preferred accuracy rate would be equivalent to the highest you could get. But that's very difficult to achieve with automated systems and different speakers, accents, and all kinds of things that play into that. Did you get a sense of what was an acceptable level of accuracy? That, like, if this was easier to use overall or more convenient, that there was a willingness to trade a little bit of accuracy off? I mean, kind of where is that on the continuum?
Yeah, we've thought about that question before, and it's hard for us to determine here because we had a small sample.
And we also only looked at higher ed, where they had no issue with providing high quality of services. I think our findings would be a little bit different if we went to a true public school where with limited resources or budget conscious.
If it's this or nothing, obviously.
Right.
60.
So I think that definitely could be a factor of what will be acceptable or not.
If you go out and look at people, there's automatic captioning for Google, YouTube, and there's a lot of bitter complaints about it.
Yeah.
That you'll find. So there's a lot of data out there already on that, and somebody could go try to analyze it and see, measure it somehow. So I think that could be found out.
That would be interesting.
Yeah.
We only conducted qualitative user experience, right? So we didn't do any quantitative for multiple reasons, like sample size, and we didn't have the access for such large data.
There's so many parameters that can affect quality. That's the thing. And it's difficult to quantify that in such a way that the user understands. If you're going to be in this scenario X, and you're going to have mic Y, and here's what's going to happen. A lot of this is predictive. The four of us, for instance, would know, but most users in the classroom wouldn't, just from experience.
Can I add one thing? I've been around the cart, a lot in my career, and most of the errors in cart, and there are errors, are semantic errors. The sequel versus sequel error, really, really common. Work on that. I think that's something that that is algorithmically solvable by, for example, inputting a textbook into the system so it knows what the language is.
Well, putting it in the language model for it.
I think that's a Microsoft problem.
Yeah.
If you have the will to do so.
Well, they have the will. So. Sorry.
What's the language model again?
So were there any domains or subjects, particular classes, where this worked much better or much worse? So I'm kind of trying to get at where is the low-hanging fruit and where is this technology just very far away?
Are you talking about CARD or AXR?
Both. But in particular ASR, I would say,
So his question was,
what's the low hanging?
Yeah, but basically his question is where there's specific subject domains where captioning services work better, and this is either ASR or CART. Correct? Am I correct?
Yes.
Okay. So this is a really good question. So actually, with one of our participants who heavily uses CART, in her math classes, she had to use ASL because CART couldn't provide accurate transcription for the math classes. And it was harder for her to follow along. So the ASL will stand next to the teacher, where the teacher is explaining equations or doing math problems on the board. So for her, she had better access with an ASL versus a captioning tool, although she's not a native ASL speaker. So we observe that across the board. So specifically for university level college, classes where they're very domain specific, it gets more complex, right? Like physics, chemistry, sciences in general. We observed that even with the Asian literature, there was issues with CART because any subject that has a domain specific words, then that lowers the accuracy. There's actually a study done at Rochester Institute that we looked at as part of our research, where they evaluated in classroom settings how many unique words, they measured how many unique words in a classroom that is 50 minutes versus TV shows that is also 50 minutes. They found in the classroom setting, there's over 18,000 unique words per class versus less than 500 in a TV show or news or etc. So that hinders. 1800, sorry. Oh, sorry, that's 0. 1800 versus less than 500. And that's what. Yes, the unique words.
Okay.
And that's in the university level classes, obviously.
For the speech recognition, were there particular classes that did better or worse?
Say that again, I'm sorry?
For the Skype translator or the speech recognition case, were there particular classes or subjects where it did particularly well or particularly badly?
We didn't, we conducted the usability with Skype Translator with 3 students, and we couldn't do it in their regular classrooms, obviously, because that would hinder their access. So we had to use either a seminar through their program or the design seminar as part of our program. So the design seminar.
And I think from what I observed, we actually did go into a biology seminar, and most of the words are being captioned pretty closely, but specific words like words I couldn't pronounce. Biology words, those are really way off. And
So special vocabulary classes that's usually where a standard recognizer would suffer the most, but that's also where domain adaptation will help dramatically. Especially those like long biology terms. Once you have that in the vocabulary, it's long. There's a lot of information to go on to get that right.
So we talked about the dictionaries, and then Richard Ledner, our mentor, also mentioned that. Like that's definitely a good problem for ASR to tackle.
And interestingly,
it's an easy one.
Interestingly, card providers also does have their own dictionary that they build up over the course of their career. The card provider we speak to say that he has 10,000 words that in his dictionary alone, and he can also build specific dictionary for specific classes that he went to. So, but even a human needs a dictionary. Why not machines?
Actually, I have that same thing with interpreters, for example. We'll have to come up with what's not known. I'll give the interpreter real time, what that word is. And if possible, before the presentation, I'll give the interpreter a list of words. Okay, you can expect to see these here. So, that's just a human thing, knowledge thing.
Yeah, actually, in this particular case, she approached me and asked, what do you want to get out of this? Is there specific things I need to know before the presentation? Yes.
So going back to the math class again, do you know if the issue was recognizing the words and the terms semantically, or was the issue just you couldn't format this in a reasonable way on the screen?
So we didn't test math classes with Skype Translator. We only asked, we interviewed the 5 different hard of hearing. They mentioned that. So apparently there's a couple really good card captioners who programmed their scenograph to be able to caption accurately the equation. It's a keystrokes, right? It's a.
And that's acceptable then?
And these are. I don't know. I think there's 1 or 2 at the university that were able to do that, but in general, it's very difficult to do. It's not semantic. It's because I think the characters that needs to be displayed as part of the equation.
And can I add just one thing? There is no standard way to express mathematics anyway, and so it is kind of, even for mathematicians, they don't always, you give an equation, they don't always say it in exactly the same way. So having the written form actually is a big advantage if you could produce it. And quite often it is produced on overhead slides or on the blackboard, and in that case, the captionist or the interpreter could point to the equation as to the. So there is more than just the captions going on in the classroom.
And that's where you also get into not being able to listen and see at the same time. You're seeing the interpreter or a captioner or something that comes up with this stream of words, and you have to take the time to look over at this equation, go back again. For us, a lot of times they're pointing at this, but you've got latency even with an interpreter, a second or two, more with any kind of text representation. So you have a lot of catching up to do.
Yeah. So that's from our secondary research, definitely came up, but we didn't observe it. It's not part of our observations.
Well, thank you very much.
Oh, thank you.
We have some certificates.